In this final video on eccentric muscle actions, we're going to focus on eccentric strength training methods, and we're going to talk about some case studies. So this is now kind of putting it all together in terms of how we might train for this. Just quickly, a few benefits of eccentric training, right, that has been proposed in the literature. We talked about possibly increased central nervous system drive, removal of spinal inhibition, improvements in maximal muscle strength, reactive strength ability, and plyometric ability. The possibility of longitudinal muscle hypertrophy, aka sarcomerogenesis, right? And the potential as well for more persistent gains in classic hypertrophy, right? Physiological cross-sectional area we're talking here. And the last point is the possibility around connective tissue adaptations, which might be important for preparing our body, developing structural tolerance, right? Developing the capacity for our tendons and ligaments to handle training load, that idea of structural tolerance again. This might be an important way for us to prepare. So let's talk a little bit about eccentric training methods. And this loading parameter table is something that we'll come back to frequently throughout the course. This is the JSCEP loading parameter table. And what we're going to be talking about today is what is shown on the screen, which is essentially plyometric training, eccentric deceleration training, so accentuated eccentric loading, and maximal eccentric strength training. And I'll just say right now that the bulk of the scientific evidence comes from what is in green, which is maximal eccentric strength training, where we see supramaximal loads being used. So this is the idea of loading that might be, we're talking, anywhere from 90% to maybe 110% of the individual's 1 RM, maximum eccentric strength training. And we already know this is going to be hard to achieve in all but a few circumstances in terms of a training environment. But associated with that, you may want to dig into this a little bit more, are some set ranges, potential tempo prescriptions around these types of training methods, and associated rest intervals. All right, let's just talk globally right now about some of these methods that we can use for progression. The first one is to use accentuated eccentric tempos. And this is the long forgotten, 50x, 80x type tempo. Very often in our tempos for an eccentric movement phase, we typically say lift or lower under control, right? But now what we're talking about is the use of slow and ultra slow eccentric tempos. For example, 8 sets of 3 at 6 RM on an 80x tempo. So you're literally lowering down to a count of 8 seconds. This is actually a highly effective way to begin to develop eccentric strength capacity and eccentric control. Remember that neuromuscular control is generally almost diminished during eccentric muscle actions compared to concentric muscle actions. So what we're able to train here is the capacity, right? We're training the capacity of the neuromuscular system through motor unit discharge, removal of spinal inhibition, right? These are the things that we can do to augment our capacity to make force in these lengthening muscle actions. And this is a great starting point. A second option is to use a combination of accentuated eccentric tempos with eccentric only repetitions. For example, this might be doing, pull-ups 4x4 at a 6 RM load on a tempo of 30x, and then doing 4 additional repetitions where the bar or the mass is lowered only with the eccentric movement. So obviously you're going to need to have assistance in the concentric movement phase. Now you either got a spotter or you've got a machine or something that will allow you to do this, but this is a second progression in our stopping point of developing eccentric strength. But I want to spend a little bit of time now to talk about this idea of developing eccentric deceleration ability. So now we're talking about eccentric rate of force development. So the fast application of force in these eccentric movement phases. Now, the video on the left is a video of somebody doing a classic, heavy sort of eccentric movement, a slow eccentric movement. And then on the right, we've got the video of an athlete performing a high RFD. It's a single leg drop, right? So she's doing a split catch with about 60% of her body mass and dropping into the bottom position. So she has to generate force fast, eccentrically, in this particular movement. It's a yielding movement, right? And I love these yielding eccentric exercises to develop eccentric deceleration ability, typically done anywhere from, let's say 30 to 80% of body mass, and done with a high rate of force development. Now, what's particularly interesting about, do we get any benefit from doing eccentric training above and beyond traditional rate training? And there's more studies that are coming out, and I just wanted to highlight this one, where what they did was used accentuated eccentric training. So basically overloaded the eccentric phase more than the concentric movement phase and compared it to traditional weightlifting or traditional resistance training in a group of highly trained rugby players. And it's really interesting to note that some of the adaptations that occurred were around the velocity of movement, right? So running speed, these sorts of measures that you see highlighted in red were all positively impacted by the accentuated eccentric training protocols. Now, you can think about why this might have occurred. There's probably neural adaptations, right? So the removal of that spinal inhibition and, possibly motor unit discharge rate going up. But we also probably are seeing some morphological changes, maybe related to fascicle length, and maybe, there's other contributors here. But what we often care about at the end of the day are these performance changes. And this is why, talking about these high RFD eccentric training methods might be of interest. So progression number 3 is this, right? Accentuated eccentric loading. I've got the old-fashioned weight releasers shown in this picture, but now what we're using, the weight releasers are allowing us to put extra load on the bar for the eccentric phase, and the weight releasers fall off in the concentric movement phase. And now what we can use are various forms of cluster protocols, like for example, an intensive cluster, where we're taking individual repetitions with 15 to 20 seconds rest between, and we're doing this with super maximal loads in the eccentric movement phase and whatever loads on the bar in the concentric movement phase. And this is a nice way to accomplish this idea of accentuated eccentric loading in a real world environment. So, our eccentric RFD ability, these absorptive movements with 50 to 60% of body mass, we can cue them differently. We can cue to be soft and absorptive, or we can cue them to be stiff in terms of how they make the contact with the ground. But what's really effective here is to pair these eccentric deceleration movements where we're working on eccentric RFD with some sort of concentric movements. We're using a contrast load here. The example given is using these split squat freeze drops, 5x4 per side at 60% of body mass, right? Catching, holding for 2 seconds and coming up explosively, and then pairing that with a trap bar clean pull, which is more of a concentric only movement. And here, doing that 5 sets of 4 at 80% of the 1RM, and using this in a paired way to train both the eccentric rate of force development and the concentric movement ability. And this is a classic pairing that I like to use. Progressions, though, are key. The key here is that we have to make sure that an individual is ready for this type of training. So I always say it starts with postures and positions. You've got to have the postures and positions. You've got to have the available range, the control to be able to handle this stuff. And then we pile upon, from these various stages, we start to progress into these high loads, high RFD, and then eventually high eccentric RFD type movements. So as we progress, we might identify, potentially first is let's look at motor control strategies. Let's look at movement strategies as a bucket to say, what is this athlete's tendency and how could we maybe mitigate any unforeseeable issues down the road that we don't want to see with sort of identifying faulty movement strategies. We may then look to develop eccentric movement abilities on the track, right? With body weight, just really drilling and developing the skill of putting on the brakes. And then from there, we might move on to these more high force scenarios. Shown here is the I am lifter, right? This essentially the athlete is resisting the downward force of the servo motor that's pushing him down towards the ground, right? To train the CNS and develop, even further around muscle morphology. And the last really interesting piece here is looking at accentuated eccentric training, right? How do we add, the component of eccentric overload, right, in a real world environment, and maybe these high RFD eccentric movements to improve, this particular type of strength capacity. So the capacity to make force fast when we're putting on the brakes. So let's talk about a couple of case studies. I think there's a nice opportunity now to drill in some of the concepts that we've learned about and bring it all together in a case study. And I want to look at the area around ACL injury. And just to give you a sense, when we talk about energy absorption ability, it's not always what it seems. So in this case, what we're looking at, counterintuitively, you look at the athlete jumping up on the right side, it's actually the injured side, believe it or not. And if you actually look at the peak vertical ground reaction force, when she makes contact on the right side, you'll actually see the peak vertical ground reaction force is higher than when she jumps on the non-injured side, which is shown in blue. You may be thinking, well, less force, is that bad? Well, the problem is she's using a stiffened limb landing strategy. So landing and amortization is really dependent on the cues. Do we land stiff? Do we absorb? This is important parts of what we're asking, in terms of our training protocols and what we're prescribing. But we also may be able to attend to this from assessments. So here, what we were able to look at through an evaluation of the landing strategy is we were able to look at the fact that on average, this particular athlete was actually landing with a more stiffened limb landing strategy on the injured side compared to the non-injured side. But where I want to focus right now is on a real ACL injury case study, and I want to look at this athlete shown here. You'll notice his asymmetries shown vertically. So the right side of the screen means that it's right side dominant, the left side of the screen left side. And you'll notice that post-injury period where we see a pretty pronounced asymmetry in the squat jump, the late phase of the squat jump. Asymmetries are up over 30%, but recovering back down to the green zone. And I want to target in a little bit on the CMJ eccentric deceleration phase, because you can also see a recovery into the green zone relatively early on. But I want to focus in more as he's coming towards late phase of rehabilitation. I want to talk about the loaded jump eccentric deceleration asymmetry. So remember, we're doing these loaded jump profiles, and what we're able to tease out is the asymmetry, the net eccentric deceleration asymmetry, right? We could also look at RFD, but we're looking at this in a loaded counter movement jump. And what's so interesting to note is that while his asymmetries are in the green zone for the body weight condition, so just jumping with body weight, we notice that the asymmetries are actually quite a bit higher when it comes to the eccentric deceleration phase for the two loaded conditions, where he's now jumping with 30% and 60% of his body mass. We can see that it was 60% of his body mass. His asymmetries are actually in the red zone. So what are we going to do about this? Well, number one, it comes down to postures and positions. And we can see clearly on the left-hand panel, this was a simple side-to-side single leg amortization movement. And what we could see is landing on the injured limb, that it was not only just this sort of strength capacity issue, there was also a movement skill issue. We can see sort of pelvic drop, loss of alignment, right? These are things that we need to attend to. It's not just strength, it's also the skill of decelerating that we need to work on. But when we go through looking at his vertical jump force time tracing with the external load, you can see where that eccentric deceleration asymmetry is occurring. You can see when he puts on the brakes, he's putting more load through the right side, the non-injured side. And what we're going to do now is we're going to have to devise a plan on how we're going to address this. So here's a classic approach that we might use. And again, I'm using this contrast load approach, where what we're going to do, if you look at the bottom panel or the bottom part of the program, is we're going to start to use combinations of split snatches, right? So great Olympic lifting exercise where, split snatches in and of themselves are actually working on that eccentric deceleration ability. It's one of the reasons I love split snatches as a form of rehabilitation. And we're pairing that with the propulsive single leg jump, right? So we're actually working on eccentric deceleration ability on a single leg basis with the split snatch. Now, the nice thing about the split snatch as well is that if he is going to get himself into unbalanced positions, right, because he's got that bar overhead, he's going to feel when he's not in right position. So now a really simple Olympic lift becomes actually a great rehabilitation tool for somebody to work on that single leg eccentric deceleration ability. And then what we see as our second indicator lift, our second primary lift, is that we're going to use a combination of a back squat, right? And we're comparing that back squat with a single leg drop off a box, where we're going to work on the skill of single leg landing, amortization, right? And we're using, again, that contrast load. So we're comparing a traditional lift with an eccentric only amortization exercise, in this case, a single leg landing into his tuck position. Now, if we look onto a second day as an example, again, it's that pairing of concentric emphasis with eccentric deceleration emphasis. So we're using here a trap bar clean pull, and we're pairing that with those split single leg, those split drops that you saw that I showed in a previous video, and pairing that with a lunge. So we're actually catching, maintaining positions and postures, and then powering back out of that position. And I think that's the key about this particular program, is that the main emphasis has to be on the quality of movement. If he's moving in a way that sort of exacerbates his technical limitations, which was really actually around being in more of a hip dominant type position, we're going to measure that things haven't improved, right? So now what we can do is we can use this to monitor his recovery and use these exercises as tools to really retrain not only strength capacity, but also eccentric deceleration movement ability. Our final example here is going to be case study 2, and we're going to be looking at an elite speed skater who was noticing on ice that in the transition of his stride that he was feeling, as he said, weak, losing pressure. So we wanted to tease out why this was happening. Well, we didn't know really where to start. This was early days, looking at counter movement jump, forced time curves. And what I began to focus on was what I was observing, right versus left side. This is a representative force time tracing, but essentially a lower rate of force development on the left and overall a lower impulse. So this was starting to tell me that something was going on that we might need to attend to. And primarily, we could do this by breaking down the eccentric deceleration movement phase from the concentric movement phase. So we take it one step further, and now we're going to look at a single leg counter movement jump. And sure enough, when we look at his right side, we see a nice pronounced first peak. That's his eccentric deceleration peak. But when we looked at his eccentric deceleration peak on his left side, what we observed was really an absence of that nice braking force that we like to see. What are we going to do? Well, in this case, we know that eccentric deceleration ability is also governed by neural factors. So turning back to some of my old research, we're using whole body vibration. It's a great way to actually work on presynaptic inhibition of the spinal cord. That's one of the effects of whole body vibration, is the removal of presynaptic inhibition. You get almost presynaptic potentiation of spinal motor neurons using whole body vibration. So we were able to take this and combine this with those amortizing type tasks, those landing tasks. Just as an aside, another place where we like to use vibration, believe it or not, is with hamstring re-strengthening after hamstring tendon autograft. Another great way to get in the back door, so to speak, and to access potential of the neuromuscular system that may be sort of blunted or hidden by virtue of the injury. So here's what we see. Throughout the training phase, right, we're now using these vibration paired up with these amortizing type movements, landings, right, really focusing on eccentric deceleration ability. We're combining it with the high RFD catches that you saw, these yielding exercises. And what we're able to observe from beginning to end using this type of training method is starting to restore that first peak that we see in the single leg counter movement jump. So now that we can, measure this, we know that we're on track towards correcting this particular neuromuscular deficit. So with that, it's the end of our 2 case studies looking at how we assess eccentric deceleration ability and giving a glimpse in how we program around this using basically eccentric training, right? So high force eccentric training, high RFD eccentric training, the skill of eccentric deceleration ability, all of these things have to be packaged together in order to make these things change. But because we've got the force plate and we've got this simple and reliable vertical jump test, we can now break this movement phase down and really get under the hood of this capacity. And all I got to say is that concentric movement abilities and eccentric movement abilities, they're not the same thing. So we got to treat them differently, we got to train them differently, and we have to test them differently.